recording if you want. Yes. Then what we say, this, so this is what we have R and S for every chiral center we have to assign. D and L, we have to look into this molecule with whether how it is related to D plus glyceraldehyde and L minus glyceraldehyde. Okay, when carbohydrate and amino acid you study, that time you will get it more. Let us come to the next part. Now here it is written, assign D and L. Now this is exercise. Let us do it. D and L configuration to each and every molecule of glyceraldehyde here. Sorry, each molecule of this one. Now let us see, before I go to glyceraldehyde, so this was this glyceraldehyde, OH, CH2OH, and this is your H, right? Now this is your D plus glyceraldehyde. Glyceraldehyde. Now tell me, what is the configuration here of this center as R and S? Tell me what it is. It is R or S?
R.
R.
You see here. Okay, let us see. 1, this will be 2, this is 3, this is 4. So what is the rotation? 1, 2, 3 rotation is coming anti-clockwise. But because this is in the horizontal position, actual our molecule should be clockwise rotation. That means this is R. So it is R glyceraldehyde, R plus glyceraldehyde. Okay. So remember that way, R plus glyceraldehyde. R is when you are getting R, the molecule is R, that is your D plus glyceraldehyde. If it is L, that means it, if it is S, this is going to be your L minus glyceraldehyde. So here there is an, yes.
Sorry. So how can we get the plus and minus in means LIVO and dextrorotatory?
No, plus and minus, that is an experimental observation. With this molecule, with this configuration, when you determine this configuration, determine the rotation in laboratory, you find it dextro. I say that one though you have to memorize, you have to, or you have to get it from, like what is the melting point of ice? Tell me. What is the melting point of ice?
0 degree.
0 degree what? Celsius, right? But how do you know? Can you see the formula and tell that what is the melting point of ice?
No, sir.
Then how do you know it? You have to do the experiment and find out. Or you know, somebody has told you, or you have seen some book. By looking at the formula, you cannot tell that this is going to be the melting point of this molecule, or this is going to be. So similarly, just looking at the molecule structure of the molecule, you cannot tell whether it is going to be dextro and LIVO. You must know it. Follow? So whatever is written, plus, minus, that is written there, it is an experimental observation. All right? Now it's clear?
Yes, sir.
Okay, I'm asking for all, whether it is clear or not. Now assign this configuration here. Now we have written here, it is glyceraldehyde. All these structures are glyceraldehyde. Now which one is your D-glyceraldehyde, which one is your L-glyceraldehyde? How to find out? Say one, structure one. This is glyceraldehyde. I have written, what is our D-glyceraldehyde? Is this one, right? OH this side, H this side, and CH2H. This is what we call it. Now whether, but it's not necessary that always I'll write CH2 on the top. I may write anywhere like, say I have written it here. This OH I have written here. CH2 I have written here. Now whether this structure is a D-glyceraldehyde or it is an L-glyceraldehyde. You can find it out in two different ways. One way is that I have already told what was your originally, your D-glyceraldehyde is your R-glyceraldehyde and L-glyceraldehyde is your S-glyceraldehyde. You find out whether this is R or S. If you find R, means it is D. If you find it is S, it must be L. That is very simple. This method is going to be very simple. So what is this one? Tell me whether it is R or S.
Yes, sir.
S.
So let us see. 1, 2, 3, 4. 1, 2, 3 rotation coming as clockwise, but it is horizontal position, so it should be anti. So this is S. If it is S, means what? What is this one? This glyceraldehyde. This is your
L.
L
L
glyceraldehyde or L minus glyceraldehyde. Simple. So you can do it for all. You take down all this. You take down all this and do it at home. Huh? Hello, I'm not doing the rest. Let me come to the next exercise. Assign RS configuration for the following amino acids. Now, what we said before I take this exercise, what we said, all naturally occurring amino acids are having L configuration, right? Yes or no? We said
Yes,
that
sir.
one,
Yes, sir.
naturally
Yes, sir.
occurring. So that is, so nature, we cannot challenge nature. Remember, so don't challenge nature. Don't say that God, if he wants tomorrow, he can make the sun rise from west. Don't say that way. Huh? Let us see this. This is your going to be D, alanine is one, and this is going to be L-alanine. And this is your D cysteine, and this is your L cysteine. Cysteine will have this side chain CH2SH. Now, this is your natural amino acid, and this one is your natural amino acid, not this one. This is not natural amino acid. It does not exist. It does not exist. All right. So uh, hello. You close the door. So this one. So let us, but anyway, from the sake of chemistry, let us do it. Whether this is going to be R or S. Tell me what it is. Tell me from this. You by now you should know how to do it. Whether it is R structure or L structure. Yes.
R, sir.
This is 1. This is going to be 2. This is 3. This is 4. So 1, 2, 3 rotation is what? Anti-clockwise. So, but because this is horizontal, so this actually should be clockwise. That means it is yes. If it is R, this should be S. Okay. That means your L-alanine, which is there, is also S-alanine. Is also S-alanine. But what about this D-cysteine, L-cysteine, which this is our natural amino acid. But what is its configuration? Its configuration, just tell me. Yes, come on, come on. Time is running out. Now, which one is your one? Group 1 is NH2, right? Which one is 2? Group number 2. Which one?
Double OH.
OH.
This is 2. Because this is sulfur. Here it is oxygen. Carbon going to oxygen. Here is carbon bonded to sulfur. Sulfur has got higher atomic number. So this is 2. This is 3. This is 4. So if this is 1, 2, 3 means what? Coming as Anti-clockwise. So actual molecule will be what? R. Actual molecule is R. So that means this one is S. This D16 is S. Now you see. Now why this is D and L is still being continued with natural molecule. Now you see. You cannot blindly, blanketly say that. Here we can say blanketly that all naturally occurring carbohydrate have got D configuration, and all naturally occurring amino acid has got L configuration. But we cannot say that all naturally occurring carbohydrate has got R configuration, and all naturally occurring amino acid has got S configuration. No, we cannot. Here you see this amino acid, which is natural, is found to be R configuration. But here this amino acid, which is there as natural amino acid, it is found to be S configuration. No, it is not. So we cannot tell in terms of in terms of R and S. So for amino acids and for carbohydrate, D and L configuration is still in use, and it will remain to be in use. So that is not going to change. Next point. Now another thing, let me just clarify. I said that all naturally occurring amino acids have got L configuration, but naturally occurring amino acid found in protein. But there are some amino acids present in other side, like bacteria and microorganisms, which are found to be L amino acid. Sorry, D amino acids. D amino acids. So that is a different story. But okay, so you should use these sentences with care. Let us see. Ask this one. Homomers, heteromers. Homomers means what? Two molecules we see, and if they have got same configuration, we call it homomers. And if they are different configurations, they are heteromers. If they are heteromers, they can be enantiomers or they can be diastereomers. So let us examine this. So here, let us take this example of glyceraldehyde itself. Now, if they are configuration, just see what is the configuration of this one. 1, 2, 3, 4. What is the configuration here? Just you have to talk in terms of RNS. What it is? What it is? It's going to be S.
Sir.
Okay.
Yes.
What about this one? Tell me. 1, 2, 3, 4. This is going to be
R.
R, sir. R.
R. What about this one? This is 1, 2, 3, 4.
S.
It is going to be S. Yes. And what about this one? This is 1, 2, 3, 4. Tell me what it is.
R.
This is going to be R because we don't
R.
change
R.
it because this is already in the vertical position. This is R. So now you see here, because diastereomer will not be there. So structure 1 and 3 are homomers. Means they are same configuration. But 1 and 2 are enantiomers, opposite configuration. And 2 and 4 are what? Tell me, 2 and 4 are what? Structure 2 and 4 will be what?
Homomers, sir.
Homomer.
Homomer, because both of them are R. So you see, now you see the funny thing, not funny thing, rather the very interesting thing. You see here, we are writing OH group here, here I have written it here, this is H is here, CH, this is all that, but it is the configuration that is going to tell you what it is, what exactly it is. It is an R, 4 is also R, so they must be same. So when they are same, we call it homomers. They are homomers. And if they are different, they can be enantiomers or they can be diastereomers. With one chiral center, you cannot have diastereomers. To be diastereomer, minimum two chiral centers should be there, minimum. So here, so they can be enantiomers. So 1 and 2 are enantiomers. Even 2 and 3 are also enantiomers. 2 and 3 are also enantiomers. But 2 and 4 are homomers and 1 and 3 are homomers. So now I think you got the, you understand what is homomers and heteromers? Yes? Let us examine
Yes, sir.
now this one, this molecule, which we have taken example earlier. Now tell me, here we have written 4 structures A, B, C, D. A, B, C, D. From here we have to identify which one is your homomer, which pairs are homomers, which pairs are enantiomers, and which pairs are diastereomers. Now here we have numbered the carbon atom because it is a carboxylic IUPAC numbering. This will get carbon number 1, this is the carbon number 2, this is going to be carbon number 3, this is going to be carbon number 4. Now, when they are carbon number 1, 2, 3, 4, which are chiral center? Chiral center is carbon number 2 and carbon number 3, right? So you have to assign each one with carbon number 2 what it is. So tell me, 2 is going to be what? This is 1. The next one will be 2. This is going to be 3. So what it is? 2 is going to be
It
what?
will be S, sir.
S.
2s, 3s.
And 3, what is going to be 3? What is 3? This is 1. This will be 2 because it is connected to chlorine. So this will be 2. This is going to be 3. 1, 2, 3 is what? It's also S.
It will be S, sir.
Okay. Now here I have, see, I have written COH group this side. Now hydrogen has got here. Now what is this 2? Carbon number 2 is what? S or R? 1. This, sorry, this will be 1. This will be 2. And this is going to be 3.
Yes, sir. Yes.
So 1, 2, 3 is this direction. But this direction will remain as it is because H is in the vertical position. So 2 is S. And what about 3? 3 is going to be 1.
3 also be S.
This is 2. This is 3. So what it is?
Yes, sir. S.
So this should be S. Yes. That means what? What it is? 2S, 3S. This is also 2S, 3S. So what is A and B?
Homomers. Homomers.
A and B are homomers. That means they are same molecules. Though we have written differently, but they're same molecules. They are homomers. Okay, let us see C. What is C? This is 1, then 2, then 3, right? What is 2?
S.
2 is S. Then what is 3? Here this one has become 1. This will be 2. This will be 3. So 1, 2, 3 is what?
It will be also S, sir.
Okay, I didn't know that. This also has come out to be same. 2S, 3S. That means A, B, C. All of them are same. They are homomers. Okay, let us check this one. Okay, while writing, I was not considering all this. I just wrote haphazardly and then you see, interest, so interesting. Is not it? They look so different, but actually they are not different. They are same. So they are homomers. Now, what about this one? This is
2s.
1, this is 2, this is 3. So 1, 2, 3 is what?
S.
Oh my goodness. Huh?
Yes.
2 is S. What about 3?
R.
1, 1. This is 2. Heck of it. 1, then 2, then 3. Okay. 1, 2, 3. So 1, 2, 3 is what? So what it is? 3 is going to be?
R.
Ah, now here it has become difficult. So what it is? What is your conclusion then? A, B, C, they are homomers. All right. Then what about C and D? Suppose I say C and D.
Diastereomers, sir.
C and D are diastereomers, not enantiomers. For enantiomers of C, what should be? C should be 2R, 3R, right? Because this is S, this is S. So your enantiomers, if it has to be enantiomers, this should be 2R, 3R, but it has become 2S, 3R. So C and D are diastereomers. Diastereomers. So also B and D is also diastereomer. A and D is also bad because A, B, C are same. Now it is clear. Now you
Yes.
see. Now you see. Now you can write any way you like. Or whether it is same or different, you have to see the configuration of that particular carbon. That is very simple, and that makes and it's become so interesting to see. You write all these things. I think you are not aware earlier. You are why what to write this way, whether we write this way or that way. You write any way you like, but ultimately you find out the configuration and see whether it is same or different. That's all. How many had joined here? Let me see. You see, only 25 people have joined. The rest could not join. We are having a capacity now. The total strength is 53. Out of 53, only 25 has joined. That means it is less than 50% attendance. We cannot have like this. So from next week, next Monday, there cannot be whether there is one person or 50%. We'll take physical classes. No online class, all offline classes. You remember, you understand what I say?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
So this is what we have to say. This is not, there are lots of other things. We have to go to top, what is called, and now let me just, recording, let me stop it here. Stop recording.